Can you hear me? Oh, okay, great. Okay, good afternoon, or rather good evening, everyone, and welcome to the last talk today about Windows Runtime in Windows 8. My name is Bart de Smet. I'm actually working at Microsoft in Redmond on the SQL division, and it turns out I've been playing a little bit in getting our builds of reactive extensions technology I'm working on ready for Windows 8 as well. So I actually have some touching points there with this technology. Now, a little caveat before we get started. Everything in this talk is based on the build content. I tried to make a pun on built on NT technology on the subtitle here. So it's built on build technology, meaning that this is all based on a developer preview. And as you may have heard, we're actually about to release the consumer preview later this month. And there's an event in Barcelona on February 29th. And so the goal of this session is really to give you a high-level overview of the Windows Runtime, what its role is, why we designed it, as opposed to give you specific details that still may change. So inevitably, there will be some samples in the code, and things might actually change going forward. So please keep that in mind. Also, if you've already seen the build content, you will see this is just repeated content, just summarized. If you haven't had the time to look at the build videos on Channel 9, this will be a good overview because it sort of aggregates 5 sessions together into one. We actually have some other talks this week as well, like using WinRT from C++. So if you're interested in that, you can always check out those sessions as well for more depth. So what's the agenda of the talk? First of all, of course, we want to answer the question, why do we have Windows Runtime? What is the goal of creating this new technology, and what's the architecture look like? Next, and that's sort of intertwined throughout the talk, I will give some samples building Metro-style applications, those full-screen, immersive, fluid applications that are touch first, using different languages, including JavaScript and C# in my case. The C++ content you can actually get separately, but you can do everything in there as well. And then finally, I want to talk really the level 300 part of this talk. It's announced as a 200, but the 300 part would be talking a little bit about how Windows Runtime works, what the role is of classes, interfaces, types in Windows Runtime, and what certain patterns are that you will actually encounter. So what is Windows Runtime really? Let's actually start by answering the obvious question. So depending who you ask, you will actually get different answers to what Windows Runtime really is. If you ask the Windows 8 team in general, or any application developer, they will associate with WinRT the act of building Metro-style applications using the API service available in Windows 8. So there are a lot of APIs that you see on this slide, some fundamentals, which include some stuff for example, threading and timers, and we'll talk a little bit about that, memory management facilities. On top of that, we have a lot of APIs that deal with specifics, like, for example, interacting with devices. Today, any tablet you buy has a whole load of sensors in it, like geolocation, GPS sensors, accelerometers, all sorts of different things that can give you information about how the device is used. Also, near-field communication sensor, you can tap devices together to exchange some data. So a lot of stuff goes in there. Then we have the media APIs. Today, it's hardly imaginable to actually write applications that don't use media in one shape or form, especially if it's those full-screen immersive applications. We have a communication stack, and on top of all of this, we also have different presentation technologies, UI technologies, including HTML5 and JavaScript, including XAML. If you are used to WPF Silverlight XAML, those skills actually transfer as well. And we have a lot of controls, of course, that go with that, also some specific controls for those full-screen applications. Now, this is one definition of what WinRT is. It's a set of APIs, just like if you ask a .NET guy, what's .NET, they might say it's a set of libraries. Now, we are going to spend most of the time in this talk looking at the other side. If you ask what's .NET, some people might say it's the CLR, it's the runtime, it's the type system. So we'll talk much more about the fundamentals and how the types work, rather than showing all the individual APIs, because those just grow. It's more important to have the skill set of how to use those APIs, how you can discover them, how you can actually talk to them. And so that's the majority of this talk will be fundamentals. So here's the overview slide of sort of the architecture from a programming point of view of Windows 8. So you see two stacks that are built on a common layer called Windows Kernel Services. So as you know, Windows 8 is built on NT technology. It's an evolution of the NT kernel, where we have kernel mode, user mode, system services, a lot of facilities that actually underpin the operating system. And then we have the desktop application stack that everyone is familiar to. You can switch to classic desktop and run classic Internet Explorer with HTML, JavaScript, add-in browsing, and all of that stuff. You have Win32, which typically C++ people use with MFC and ATL and all of that stuff. And then you have the C# VB managed code layer that's running based on Silverlight and or the CLR. And so that's what the desktop applications are, and we all know what those look like. Now, next to that, we have this new style of applications, the Metro style apps, which are full screen, touch-centric applications. We call them immersive as the experience, or to describe the experience. They're fast and fluid, lots of qualities that we actually want to have for a touch experience that's really good. And so those Metro style apps actually are based on the Windows Runtime API. That's the way you interact with the system, as opposed to having different ways to talk to the underlying operating system. WinRT really abstracts over all the OS capabilities for all those languages that you see on top there to write those immersive applications. So if you like to use presentation using XAML, you can use C#, VB, and even C++. If you like to use web technologies, because you've learned web technologies, without actually sacrificing any of the WinRT capabilities, you can use HTML5, CSS, and JavaScript as the language to program against the WinRT set of APIs. So it's really a common layer of APIs accessible to all those higher level languages. So in summary, and this doesn't conclude the talk, it's just to sort of have one key takeaway if you want to describe to your neighbors what WinRT really is, well, this should be the sentence. It's the foundation to build those solid, fluid applications that we call Metro-style apps. So it's actually the API that you use to power those applications. So now let's take a look, zoom in into that left section of the Windows 8 developer stack and look at the runtime architecture of Windows Runtime itself. So at the bottom, we have the Windows core, which we talked about before. Kernel mode, user mode, system services, a lot of capabilities. And in fact, WinRT should be thought of as an interface on top of all of that. Ultimately, you can think of WinRT as being part of Windows core, but for the sake of, drawing the distinction here, I've just built up the slide by putting a little rectangle on top of it that says, the Windows Runtime core sits on Windows core. That's sort of how you can think of it today, but you should really start thinking about it more and more as the API to Windows, as opposed to being some layer diagram there. Now, on top of that, we have, the first slide I showed you with all the APIs, which I won't talk about in detail. I will pick just a few to show you some key concepts. But so you have all those APIs on top, and all of that is now actually backed on the side with rich metadata, the Windows metadata or WinMD, as well as namespaces. It's organized in a hierarchical namespace. It's an object-oriented API. And so by having metadata as opposed to header files and all sorts of, Win32-style idioms, by having rich metadata, you can have rich tooling. You can have an object browser, you can have IntelliSense, you can have all the things that managed code developers actually already know, but now for the entirety of Windows. We don't have to wait for somebody to do the port pinvoke and the COM interrupt stuff in order to access the richness of the operating system. It's just exposed as metadata so tools can directly bind to it. On top of that, we have so-called language projections, and we'll spend a fair amount of time talking about those. So language projections look at Windows Runtime and expose the facilities in a way that's familiar to the developer. If you're a C# developer, you want to see your collections like ilist of t and IEnumerable of t and all of those things. But if you're a JavaScript developer, you want to see them differently. For example, you want to see ilist of t as a JavaScript array that you can do map and filter and for each on. And if you're a C++ developer, well, you want your begin-end iterator pairs and all of that stuff. So language projections introduce a small, tiny layer, depending on the language you use, that makes things look familiar to you, but are actually just based on the same common foundation. On top of that, you build your Metro-style apps in whatever language you see fit, and you can actually interoperate between those guys as well. And then we have some additional runtime services next to it, such as a runtime broker, that actually allows to create an object, a brokered object, that, for example, presents a prompt to the user to say, is it allowed to access the webcam? So we have some facilities to do those kind of things. On top of that, or well, actually alongside that, we have a web host, which runs your JavaScript applications. They don't run in a browser, they really run in a host process called wwa-host.exe, which runs the Chakra JavaScript engine, as well as the Trident HTML5 and CSS engine to do the rendering. And besides all of that, you also have language support that's built in to actually support WinRT. If you went to my Future of C# and VB talk, you saw that the CLR and the languages sort of know a little bit more about Windows Runtime to make it as fast and fluid for you to basically talk between those two worlds. So the CLR had to gain some knowledge of how to do addref and release semantics. Chakra, the JavaScript engine, had to do that as well. And CRT has some extensions built in as well that support Windows Runtime. So all in all, the developer experience that you can see over here, that's our mission. It's to build those Metro-style apps with a great developer experience. Unlike, for example, the poor C guy that's using Win32 and needs to know that create window and destroy window are two functions that pair up. Like, they're in a flat namespace, that's the first thing. You have thousands of functions, and then you don't know how they relate to each other, like a lot of things that you have to deal with if you're in that camp. So we want to improve the developer experience tremendously, and then we also offer you freedom of choice. So the idea there is that there is no single golden way to create Metro-style apps. If you like HTML5, CSS, all of that stuff, you can use your skill set. If you like to use XAML, you can use that skill set. If you want to use some third-party library, include it in there, you can do that. It's JavaScript, it's C#, VB, C++. You can actually add those things to your projects as well. So it's also about not picking one golden way to write those apps, but give you choice. So what are the design principles in designing WinRT? A lot of things here. First of all, I already mentioned it, have this great developer experience, which is possible thanks to the metadata format that we have, and I'll show you that in a moment. It's also about responsive and fluid. You don't want to sit on your touch-based machine and just swipe something and the whole thing freezes or whatever. So at the core of Windows Runtime, about 10 to 15% of the core APIs that kick off operations, like capturing things from a camera, doing near-field communications stuff, interacting with the SMS API, those are asynchronous at their core. So there is no synchronous variant of those. And the rule of thumb actually in the design principles of WinRT is that any operation that can take more than 50 milliseconds has to be asynchronous. There's no synchronous variant of those functions. You have to go asynchronous. And that ensures actually to have responsive and fluid applications. The platform is app-centric, which means that if you install two apps alongside each other, they can't interfere with each other. They're really isolated, apart from those well-defined contracts that you can actually set up in your application. So for example, if you want to share photos between applications, you can set up that contract. But other than that, they're really isolated entities on the operating system. So they can't start interfering like in the classic DLL hell, for example. And finally, there's platform-based versioning, meaning that objects, classes in the WinRT can gain interfaces as they grow from version to version. But that also ensures that, if you're targeting, say, Windows 8 as the baseline, you will just see the interfaces that were in Windows 8, and your application continues running, even though the objects in WinRT might actually grow capabilities over time. So something that works on 8 will work on future releases. That's the idea of platform-based versioning. And we'll talk about how that's actually accomplished, or that's accomplished in the operating system later. So let's actually just get started by creating a very small, simple JavaScript application over here. Just switch to the other machine. I'm actually starting with the classic desktop, which wasn't the IDE. But let's actually, so this is the experience, by the way, you've seen it before. So that's the start menu. You have those rich applications that you can open up, and you can just swipe between the applications and just do a lot of cool stuff. And we want to create those full screen immersive applications ourselves here, like a weather forecast application that connects to the internet, and in the meantime, the app was still responsive or the UI wasn't frozen over, and so we want to create those kind of experiences. So let's actually just, and I actually promise you, the demos I will be doing will be pure Hello World style apps, and then we'll look behind the scenes how certain things are actually done, so that you actually get the key concepts as opposed to getting lost in certain API details. So we'll actually start with a JavaScript Metro-style app, and we'll make a blank app, and we'll call it WinWeb App 12, which is a great name. And so let's give that a second to load. Visual Studio will create an HTML file, which you can see over here, some JavaScript and CSS files, and create a project around that that also has this manifest next to it that actually describes the application, like what the logo is, what the title is, what the start page is, a lot of stuff. And we'll actually see this one later on. We'll actually have to dive into it a little bit. So what I want to do here is I want to have a file picker dialog. I just want to go to the file system and basically allow the user to select some image. And so do that using the WinRT. So I'll just enter some script in the same file here. I could put it in a separate JavaScript file, but I'm just going to do it over here. Let's just insert a script tag. That's what we know from web development. And I'll create a function called foo, great name, and interact with Windows Runtime a little bit here. And I will make that the function that's triggered when my application loads. So like this. And in my body, I want to have an image tag, which has an ID that I will call img. Oh my god. Okay, so we have a foo method. It will just get, or foo function, it will get executed upon loading the application. Now I want to talk to Windows Runtime. Where do you find Windows Runtime? Where do you find the APIs? The answer is it's namespace based, so you can just dot into Windows, and then you will find all those capabilities. So let's do file picker dialog equals new Windows dot, and you see full intelligence for the application model, data, devices, foundation, all of that stuff. So you can start talking to devices here, like if you want to talk to the GPS, you can just new into that and start parting on those objects. So in this case, I want to go to the storage API. I want to go to the pickers namespace, where I actually have a file open picker, as you can see over here. So I'm just newing one up, and it even has some intelligence that says it creates a new instance of file open picker, which is not much of a surprise, I guess. And then we can start setting some particular options on this guy. And so let me actually add some file type filters so that I only get things with a certain extension. Oops, sorry. File type filter. And let's dot into that. And what you're seeing here is really a JavaScript array. I'm doing fpd.fileTypeFilter, and those are the methods that, if you ask a seasoned JavaScript developer, will say, this looks like an array to me. It has all those nice methods. It has filter, it has map, it has for each. It also has push to add something to the array. So this really looks like a JavaScript array, even though behind the scenes in WinRT it's implemented as an I-vector of t inside C++. And if you would do the same thing in C#, you would actually see it surface as an I-list of t. So the projections take away specifics of the platform and abstract it using the language-specific and natural and familiar ways of doing it. So I'm just going to add JPEG and PNG files over here. And now I have fpd, and I want to kick off the act of selecting a single file. And so you see pick single file async as one of the methods. It's async because, well, the user might take longer than 50 milliseconds to pick a file, of course. So, you will see a lot of those async suffixes in the APIs. So I'll do pick single file async, and what this thing returns is a pick single file operation, as you can see over here. So it knows the type information from the metadata. We'll look into that in just a moment. But this is really an asynchronous operation. And now, depending on the language, you use the natural way of interacting with that. If you're inside C# VB, you would use the new await keyword in front of that. You would just await, and you would get your file. In this case, I'm actually going to use promises in JavaScript, which use the then function, and pass in the callback that will actually receive the file over here, and then do something with the file that has been selected. And in fact, at this point, I could already do something like, say, debug.writeLine. Just give me something here to get the full path name or something, and set a breakpoint on that. And we'll already see this application doing something. So let me actually run this and see what it looks like. There we go. I have a nice file picker, which is uniform in Windows. So no matter who actually uses this will actually get to see this. We can select the folder to go to, or even applications that expose pictures. We can dive into applications that have picture catalogs. which expose that and say we have an app-to-app contract that exposes the pictures. But so I'll just go to the pictures folder, select the picture of Ghent over here or something, and do open, and ta-da, there you see, this breakpoint being hit, and we see a string coming back from WinRT that has this whole file information. Of course, I want to bind it to the UI, so let's actually try that as well. So I want to convert this file to something that I can use on the image tag. So I want to do image.source, full IntelliSense here. And I need to give it some, identifier, like, file system is not really, because it's isolated, it's not the way to go. But we have some function, window.url, that you can use. And here you can create an URL for an object out of WinRT. So I can do create object URL given the file. And that will cook up some URL that can just access that particular thing. And you can even specify whether that content is reusable, whether or not that stuff can be reclaimed after you use it once. So I'll just put this thing in here and see how it works. So let's pick the picture again. And there we go. We have the image tag actually rendering the picture. Pretty nice. So pretty simple to do. And so that actually shows how to interact with the WinRT. You've seen full IntelliSense. You've seen how to do asynchronous operations, in this case in JavaScript. We'll see some managed code later. But so the essential idea here is to have access to all those APIs no matter what the environment is that you're coming from. Whether it's managed code, native code, JavaScript, you actually get access to all of those things. So let me actually stop the debugger here. Oh, whatever. So let's take a look at what's going on inside a Windows Runtime application. We've touched upon a lot of things here. We've touched upon the storage API, which is just an API. We've seen the web host, which was the thing that showed that little clock with a blue background and then rendered the application, running my JavaScript code. We've seen the projection at work because we've actually dotted into an asynchronous operation using then. We've talked to an array by means of a JavaScript array. But let's first focus on the Windows metadata and the namespace structure that we actually have. So let me actually just finish this guy here for the next demo later on. Just a second, okay? So, okay, that's in a good position. Otherwise, things might start timing out. So what's the Windows metadata really all about? The Windows metadata is the key to having this rich developer experience that you actually saw even in JavaScript. Even though it's a dynamically typed system, it got access to all those namespaces and found a lot of information, IntelliSense of all the things I was doing. So it's a concise, complete description of everything, every API in Windows Runtime. There is a catalog that contains all this Windows metadata. It gets generated natively if you build components for WinRT in C++, C# or VB. In JavaScript, you can't really write objects because they don't have type-level declarations. But so in the other languages, you can create your custom WinMD objects or Windows Runtime objects. The format that's used to represent all this metadata, like what the members are of types, what the types are, what the namespace structure is actually based on the CLI, which is the metadata format that the CLI uses. If you want to look it up, it's ECMA 335 is the standard. And so it has the same structures, a couple of little things that have been tweaked, but in essence it's the same, which means that things like Visual Studio just work, object browsers just work, ILDevim just works, FXscope just works. So that's a great reuse of technology. Metadata is rich enough to have those language projections, so it contains enough information for languages to do the right thing. And of course, on statically known information, we get this rich IntelliSense. Now, from a logical point of view, the way that WinRT is structured is in a hierarchical namespace fashion. So you just dot into Windows, and then you see the subnamespaces and so forth. It is just one place to go to find everything that lives in Windows Runtime. So, of course, that gives us great IntelliSense, browsing experience, all of that stuff. There are places just to go, like you find a certain type, and you can say, well, that type is a file picker. That means it does everything that has to do with file picking. So you actually just find your types, and then you dot into them to do the operations. And the catalog, as I mentioned before, is extensible, meaning you can create your own Windows Runtime objects in C++, C#, Visual Basic. You can't do that in JavaScript. But when you actually deploy those WinMD files that extend Windows Runtime, they're private to your application. there's no central registration of those additional WinMDs that you create. You just deploy them with your app, and that avoids all sorts of clashes where one app can sort of tamper with the structures of another app. We don't want that kind of stuff. So there's the blessed catalog, which contains the Windows Runtime APIs, which may grow over time. And then you have your own custom extensions that are private to your applications. So here's the type system, or some of the primitive types. Sort of like always when you design a new language, you need a new string representation. That's no different in Windows Runtime, but for a very good technical reason, actually. The H string type that you see there, H, typical convention in Windows for handle, even though that's sort of not really the way things work. But so H string, typical naming convention, what the beauty is of that guy is that language projections don't have to do copying. Like you have an H string, you just send over the pointer, and all those languages can interoperate with it without having to copy the string. Of course, then if you're in, for example, CLR world, and you have that string, and it's projected like a system.string, and you do something like .substring, which, as we know, strings are immutable in the CLR, creates a new string, well, at that point, of course, you get copying, but that's the behavior you always got. At the boundary between WinRT and, applications or, those libraries, you don't have copying behavior. So a string that originates from C# and goes to JavaScript, there's no copy involved. Then we have primitive types, like int32, uint, and we also have some pointers in certain cases. We have flags, represented as enums, enumerations, which you all know and love from the managed world as well. So we have those to configure APIs typically. We have structs, which are just name-value pairs of fields. They don't contain any operations, like a struct cannot have members on it, can just have public fields that can contain strings, but they can't contain other interfaces. So things like size, which contains 2 int fields, that's totally fine. Something like a person that contains a string and an age, that's totally fine as well. But you can't have a struct to bundle up interfaces. Next, we have simple arrays, just for very simple collection types. We also have interfaces, which is very important, because WinRT is really an interface-based technology. Just like COM, for example, is an interface-based technology, WinRT builds on that to some extent and adds a lot more. But the interfaces is sort of a very powerful concept in WinRT. Now, at the same time, you don't have to see those interfaces yourself as an app developer. As an app developer, you're interacting with runtime classes which implement a lot of those interfaces. But we'll see later that interfaces are the essence that allow us to do versioning and all sorts of good things. And then we also have generic interfaces like I-vector of t. So now everyone who actually uses, for example, C++ can have those statically typed vectors that actually also work across boundaries. An I-vector will actually be projected into an array in JavaScript, will be projected into an I-list in the CLR. So that's an overview of the basic types. So let's actually take a look at this Windows metadata now. Like, where does it live and how can we actually interact with it? So let me actually switch over back to the other machine and take a look at the Windows metadata. So where can we find metadata? Well, as usual, all good things in Windows live in the System32 folder. So we'll actually just open a command prompt here and actually let me boost the font size just a tiny little bit here. Okay. It's beta, or developer preview. So let's go to the Windows folder, System32, and then we have a folder called Win Metadata. And so the Win Metadata folder is just a single folder that contains a lot of so-called WinMD files. WinMD stands for Windows Metadata. And so here you see all the Windows Runtime APIs that are available. So it's all self-describing. You can go to a central location in the system, and there you will find all the metadata of all those guys. As I said to you before, this information is actually based on the CLI, the CLR metadata format that we actually have in .NET as well. So I can just go into those guys by using tools like ILDASM, the IL disassembler. So let's actually open this Windows Storage Pickers WinMD file that we were looking at before using ILDASM. Here we go. This one doesn't remember font sizes, so I'll just boost the tree size here to 14. And here we go. So as you can see, this looks like an IL file, like an assembly.NET assembly. You see one difference already over here. It's an assembly with some little piece of metadata. That's one of the extensions to the metadata that is a flag on the assembly level that says this is a Windows runtime file. It's not a classic .NET assembly, and in fact, it doesn't contain IL code. It just contains the metadata describing the APIs. The APIs are built inside the Windows operating system using native code. But so they expose themselves using this metadata format. And so the file open picker that we were looking at before, as you can see, is actually a public type. It's Windows runtime type, and it's sealed. We'll see later that those things tend to be sealed all the time. We have an interface that we implement called iFileOpenPicker, very essential to the way that Windows runtime works. And then we have those operations like pick single file async that we actually used in JavaScript with a lowercase p, because language projections surface those APIs in the way that's familiar to the user of the language. So in JavaScript, things tend to start with lowercase, so the projection renames that thing sort of at the marshalling boundary, or the communication boundary. Now, if you go into those guys, well, you don't really see anything other than the fact it's an override of the implementation of the interface. But so it's just a virtual, like it's the same metadata, but it doesn't contain an implementation. The implementation of this type is actually found to so-called activation store, which lives in the registry. So ultimately, these types come from a DLL, like system, shell32.dll. But so the Windows metadata purely describes the structure of the system, not its implementation, which is a detail as far as usage is concerned, of course. Other than that, you have some other things here, like you have those guys, which are properties. And we actually looked at one of those properties, the file type filter. And if you look at the file type filter that we used in JavaScript just a moment ago, it exposes an I vector of string, a generic type. And so, as you can see, all those things are just the way you expect them to be. And the file type filter has a getter only. As you can see, it has a get method. And so it has a get file type filter over here, which returns that vector to which you can add things. And the projections say, well, if it's a vector, in the CLR it will look like an I list. In C++ it will look different. If you use it in JavaScript, it will look like a JavaScript array where you can do push operation. So that's actually where the Windows metadata lives in the operating system. So let's actually switch back to machine 3 and talk a little bit more about what those Windows runtime objects really are. We've seen the type definition, we've seen the members, we've seen the namespaces, but what's really going on behind the scenes of those runtime objects? And the nice thing about all of this is that in order to write applications, you could already have left the room in some sense. Like, you know how to dot into the Windows namespace? You just use your language features, async and await in C#, then in JavaScript, collections, all of that stuff. But let's take a look at how things actually work behind the scenes, because that sort of illustrates a couple of points, like versioning and those kind of things. So now let's actually look at the role of the Windows Runtime Core, which is like the type system, and then what the language projections on top of all of those APIs actually do, what their role is. So here's the structure of a Windows Runtime object. This is the file information object that you could actually find in the WinMD files as well. And indeed, if you would look in the Windows metadata store on disk in System32 Win metadata, you would find exactly this type. And if you look at the runtime class, the file information class, you would see it implements a number of interfaces. So it implements iStorage item information, it implements iStorage item, iStorage file. It also implements some well-known interfaces, some base interfaces, foundational interfaces. It implements IUnknown. Windows Runtime, at its heart, is based on COM technology. It adds a lot of things to it, but at its heart, for memory management, it uses addref release semantics. And it's an interface-based system, which means that you can walk to an object and say, I want to query you for a certain interface, just like doing a type check and conversion, and then getting an instance of that interface back. So that's at its heart. But on top of that, because everything has rich metadata, we added this interface called IInspectable. Now, some people in the Windows Runtime team, the story goes, wanted to call this interface IKnown next to IUnknown, but that was kind of too confusing. It sort of sounds the same, so it's called IInspectable. And for managed code developers, the way to think about this is pretty much like system.object. It has some additional capabilities, such as the ability to describe its type. Now, how do you create one of those objects? We've seen where the metadata lives. We've seen that there is an implementation, in this case, in shell32 DLL. Now, if somebody creates a new instance of this file information object, how does the activation work? Where does the object get created? And the answer is there is an activation store in the registry that ties the pieces together. It says, well, I want one of those guys. I know where the DLL lives, and I'm going to activate an instance of the object based on that DLL. And we'll see the activation sequence later on. But this also allows us to create instances of that object in process, but also out of process. So for example, the way the shell, Windows Explorer, interacts with your application for those interactive tiles is basically that it holds on, or it actually references an object that lives in your application. So it's really an out-of-process object that it's talking to. Things that the COM folks have looked at before, but now actually in a modern fashion with IInspectable on top and some additional muscle mass added to it as well. So it's a much extended system compared to COM, but if you know COM, it's definitely something that was a good investment in terms of learning about it. So now we have this object sitting here. What do the projections do? Well, as I said before, the projections surface those APIs in a way that's actually natural to you, depending on what language you're using. So here we have different languages, C++, C#, VB, and HTML, and we have the Windows metadata store. The question here is, when do we talk to the Windows metadata store to basically create objects and those kind of things? Well, if you're using C++, the Windows metadata store is purely a compile time thing. At compile time, we know where to find the objects. They live in shell32, for example. We can generate code in the projections that immediately accesses those objects. If you're talking about C# and VB, you have things like memory managers there, like garbage collector in the CLR, that rather wants to know when an object enters, it needs to up the ref count, and when it leaves, it has to remove the ref count. So the GC is there, and there are some other reasons that the CLR needs to know about metadata. But so it's a combination of compile time querying of the metadata. When you're doing the object browser, IntelliSense, at compile time, we know about the WinMD files. And in fact, if you look at the command line, when we compile a C# application that uses Metro, you would see all the WinMD files added to references. Like you would see /r, all the WinMD files. So at compile time, we're looking at them, but at runtime, we're also doing a little bit of querying of the Windows metadata store. And then HTML, JavaScript-based apps, well, it's an interpreted language. What do you want? Like, in interpreted systems, you don't have a compile time. So in other words, when you actually use Chakra, which is the engine of JavaScript that we use, we'll actually query the Windows metadata whenever you're doing stuff. Of course, at design time, in Visual Studio, when you're dotting into those APIs, we're querying the metadata as well. But other than that, it's purely at runtime that the metadata sort of is read, and that, for example, the projections create nice little wrappers around the objects to make them feel JavaScripty. So let's walk through the sequence of creating an object. Really, the app doesn't need to know anything more than this is the type. I want to create a new file picker. But what happens behind the scenes? How does it actually do that? Well, first of all, the app, of course, asks to create an object, which is in the green zone here, which is the application code. And the app talks to the projections. So the projection is the language-specific exposure of Windows Runtime. And so that takes the name of the type and passes it to some function called rowActivateInstance. RO is the prefix in Windows to indicate those Windows Runtime APIs. And then, that thing will actually look in the catalog in the registry and say, I want one of those file picker things. I know it's in shell32 and it lives over there. So it will actually find the DLL using the catalog where all those things are registered. It will load the DLL, and it will actually call something called DLL getActivationFactory. And that thing is now responsible to new up an object, whether it's in process or out of process or anything, any activation mode we support. The object manager actually talks to the activation factory, and ultimately, well, the object gets created by the implementation code somewhere. Ultimately, this thing returns an IInspectable, which is the base type. So we have an object now. It's like a void pointer in some sense, but with the lowest common denominator type that's in WinRT, which is IInspectable. And then the projection looks at that thing and says, well, it's inspectable. That means I can look at how it's structured, what all of the members are, and all of that stuff. And the projection now can choose, whether it's at compile time with C++ or at runtime, with things like JavaScript and CLR, it can start creating a little wrapper using the metadata. it can look at the metadata to the inspectable and say, oh, this thing looks like a vector. I want to expose it as an ilist of t in the CLR. This thing looks like, an asynchronous operation. Let's map it to this interface or a promise in JavaScript. Like all those kind of things is what the projections do, and it's as tiny as possible for efficiency reasons. So it's not like huge amounts of code being generated. It's actually just the shortest path to get to the object. Then the object that we got back, the inspectable, is bound to the wrapper. So the wrapper points to the original object, and now you can just talk to the wrapper. That actually exposes things in the way that you expect them to see. So the application gets the object, and lo and behold, we can start talking to it. So what about versioning? I alluded at that a couple of times. Well, you have an object, nice lollipop diagram, inspectable, unknown. Those are the base things. 3 interfaces implemented. This is how it looks in the Windows metadata v8 store in Windows 8. And we have an application that talks to this guy through some projection. Now the question is, when we move to a future version of the OS, how does it look then? Well, the 3 lollipops on the side are still the same. We just add some interface to it that adds the new capabilities to the system. And so when you build your application and you say, I want to target Windows 8 and higher, that orange interface will not be available, because it's not a common denominator between all the operating systems that you want to target. But if you don't touch that interface and you say, I just want to use this type, your application that was built in 8 still works in 9, because it still has exactly the same interface as it used to have. It's purely additive, adding stuff to it. So that's how versioning actually pans out. So let's actually talk a little bit about how to do those cross-language projects in Metro that actually use different languages to expose WinMD objects. And in fact, in my C# talk, I gave a little sample of that already, but let's actually talk a little bit more about this over here. So let's close this guy down and just create a new project in VS here. That's nice performance. So let's create a new project, and I'll start again with a JavaScript guy, but I will talk to some C# or VB in the background. So I'll call this WinWeb application 13. That's my lucky number today. And it's just a blank app, and I'll just try to get some objects from, say, managed code in this case, and try to get them into JavaScript and see how it looks. So how to do that? Well, you want to create a new solution or a new project next to it. And it's been a long time since I've used some VB, so just to convince you that you can use VB as well, I'll use class library VB over here. So just create one of those guys. And so what I have now is a typical CLR, .NET assembly. Now that's not sufficient to make it work in WinRT. You basically have to build it as a WinMD file, which has that metadata on top of it. So you just have to change the output type of the project. So we go here, the application type was class library. I'm going to change it to a WinMD file. So there we go. And now let's try to build this guy. And we'll actually already see one issue. We see 2 errors here. First of all, class 1 is unsealed, but not enabled for composition. What does that mean? Well, WinRT types that you expose to your WinMD files actually have to be sealed. Can't be inherited from cross languages. So that's the first restriction that's in there. Now, if you're actually building controls for XAML, that's actually what we mean with this composition stuff. When you actually write XAML controls, you can actually use inheritance because those are based on inheritance, but that's sort of the only exception where inheritance is used. Other than that, your types need to be sealed. The second thing it complains about is something about the default interface for this runtime class. It already reveals the secret that this thing will become a runtime class to WinRT. But every class needs to have an interface that describes its members. Now, if it's empty, there isn't much to be said about this thing. Like, the only thing you would use an empty class for is identity, or just I inspect it and find nothing back. So you really need to have something on it. So let's actually satisfy those 2 things. Sealed in VB is not inheritable, which is really what it means. I will call this thing class 1, and I'll add a public function to it. Let me say get greeting that takes in a name as string, returns a string as the function, and returns from the function hello, comma, And I could use string.format because really this is running in the CLR. I can use all the capabilities of the platform. So let's just use string.format over here, hello 0 with an exclamation mark, and then pass in the name. So this is string manipulation. I've never learned how to do this in JavaScript. That's the thing I want to do in the CLR because I know how to do it. So here we go. That's something I couldn't have written in JavaScript. So that's why I want to use this interoperability story. So now that I have this, let's try to compile it. And as you can see, 2 projects succeeded. I got the WinMD file there, class library vb.winmd, which is that metadata file. And we got an appx recipe, which is really the format that Metro-style apps compile into. So let's actually just go to the developer prompt once more, and I'll desm that WinMD file that got generated. So here we go, just to show you that what the compiler generated is, as you can see over here, an iClass1 class. Okay, there's some name confusion here. Well, actually, it's just a pattern. But so here you see there is an interface generated, the Windows Runtime interface, to talk to this object. It has a get greeting, taking in a string, returning a string. And then, no surprise, of course, class 1 implements that interface. And then there are some specifics that Visual Basic does, the my namespace, that's not a surprise in VB. And then some other guy here, the CLR side of that interface. But so the essence is that there is an interface, and that's the way we actually talk to the outer world. Now, compare that to classic COM. If you create an object and you want to expose it to some native guys, or some other, users of COM, well, what did you have to do? You had to dream up a GUID and put it somewhere, and COM visible the thing with an attribute, and do all sorts of crazy things just to make this work. You had to create your own interface. Like, a lot of things are being taken care of now by the tool chain, in this case, the Visual Basic compiler distilled this interface. So I have this thing now. I can go to WinWeb app and add a reference here to my class library VB. Here we go. And now in default HTML, let's just create a div tag, which will be greeting, like this. Actually, my HTML skills are super because I can even do font sizes. Woohoo. XX large, so it's readable. Okay, great. And then I want to create a little script. I'm just, again, going to be lazy, not going to the default.js file and put things over there. I'm just going to inline the function here. It's HTML. I can do all of that stuff. I'll call it foo again. That's not a mandatory name, of course. But so I'll call JavaScript in the onload function. And then over here, lo and behold, I can actually do something like var CLS for class equals new class library VB. And as you can see, we have IntelliSense. In fact, I could go to the object browser and look at that thing just using all the familiar tools I have. I can go to class 1 here, new it up, and do cls1 get greeting somehow. What's going on here? Oh, cls1 doesn't exist. Okay, cls. I have a get greeting method, which used to be capital cased with G, but in JavaScript, we surface things using the naming conventions of JavaScript. And I want to say hi to WinRT. And then this gives me a text back. And in fact, I can bind it immediately to this control. Greeting.inner text equals get the greeting that says hello to WinRT. And so now when I run this app, we should actually see the Metro-style app written in C#, written in JavaScript that's running in WWA host.exe, which is the hosting process, talk to Visual Basic to do some string manipulation functions. And so there was no string copying involved in this case. As I said before, the H string type takes care of that. So we got very smooth intro between the two worlds. So now just to show you some other patterns that we can expose, let's go back to the VB project here and say I want to actually have a public shared sub bar, which is a static method in C#. And let me not do it anything, just to show that you can talk to static methods as well. Let me compile that. In fact, I could have gone immediately to this file. And now when I'm sitting here, I can go to the class library, and I can start dotting around, and I don't know how I called it anymore, bar. Oh, there it is. So you see the static method bar also surfaced on this object. So static methods, instance methods, all of that stuff works. And now to show some more projection stuff that we can do, let's actually create a function, foo, whatever, that returns a ilist of int. not of synth, we're not in December yet, and we'll return a new list of integer like this that contains 2, 3, 5, 7, 11. Prices can be 1 for people who know what this sequence means. End of statement expected. Okay, it's been a while since I've used VB. I'm not sure whether they have collection initializers. I believe they do, but likely the syntax looks a little bit different. So dim lst equals that guy, you know. I know. I need more params. When in doubt, add more params. Okay, that solves the problem a little bit. Integer cannot be converted to collection of integer. That's interesting. Dim lst equals that guy. I'll figure that out later. List.add 2, just to show you that I can, you know, somehow return a list like this. And in fact, you know, I should fresh up my, you know, skills in VB a little bit. But so here we go. Some nice prime numbers. Oops, I gave it away. So we have a list sitting here. Let's take a look at how that list looks in JavaScript. So let's now go back to default HTML. I have that class. I have created an instance, was an instance method or instance function, right? So I can go here, do foo, and now look at this. It actually surfaces as an I vector of t, an I vector of number, which is the, you know, generic interface type that Windows Runtime uses to specify those lists. In fact, in the CLR, we now also have I read-only list, which is a read-only list which would map to I vector view, which is the read-only type that we have in WinRT. So now that I have this list, I can go to it and look at it. You know, I have all the JavaScript stuff that I'm familiar with. I can do a for each loop over this. I can do something like get it something at a certain index. I can do filtering, all sorts of nice things. So I could do for each function x for all the elements in the array, do something like, I don't know what, you know, greeting.innerText and, you know, do greeting.innerText dot, for example, plus equals. Not sure that actually even works in JavaScript, but so you can now actually get all those integer objects out. And we actually saw before that this thing returned a, you know, as you can see over here, an I vector of, an I vector of number, so that it even knows in JavaScript that those things are numbers. So I could use, you know, things that are specific to the JavaScript number type. So this is just a couple of examples of how the projections actually work, what they do. Now, let's show one more thing. Let's actually talk to some other APIs from inside C# to show you the power of async combined with WinRT. I already have a nice collection there of applications with numbers that don't really say much, but let's go to C#, create a little application 5. And now talk to the WinRT APIs and consume this async stuff using just, you know, the things we know in C# 5 and VB11, which is async and wait. So let's just wait for the designer to wake up. There we go. And, you know, my skills in XAML are limited, but I know how to create a column, which is great. By the way, I used to work on WPF, so it would be a shame if I wouldn't know how to create a column. So here we go. We have a button. That's beautiful. And we're also going to add an image. And the editor even allows me to dock the whole thing over here. And now I have the button sitting here. I have the image control. Let me actually try to get to the properties window. Help, where's the properties window? Here we go. So where's my image control? Oh, here we go. Grid, well, you know, I know how to do XAML as well. So let's actually just go to the image and give it a next name, which I will call photo, which will contain a photo that I'm taking. So that guy has a name, and now I can go to the button and add up an event handler. All stuff that, you know, everyone who's done XAML knows and loves. So just making a click event here, and so I have a button click, and, you know, everything is very nice. So now what I want to do is I want to create a camera capture UI, which is the way to interact with the webcam on my device and actually allow people to create pictures using the WinRT APIs. So I'm going to call this camera, and I'm going to do new windows.media.capture.camera capture UI. So I'm just going to create a new object of those, of that type. and then look at the camera object, and you can see I already have some way to capture files async. I have ways to configure the photo settings and the video settings. In this case, I want to create a picture, so let's go to the photo settings, and for example, specify over here the cropped aspect ratio, which means how you can crop the picture such that things actually have right dimensions. Now, as you can see over there, there is something associated capabilities that you see when you look at those APIs. Those are capabilities that you need to declare in your application that you want to use, so that Windows can actually ask for permissions to the user whether or not you want to allow the application to talk, for example, to the webcam. So I'm going to do a cropped aspect ratio just by 4 times 3, like classic ratio. And now what I want to do is, well, I want to take the picture. So camera capture file async, and pass in the camera capture mode, which will be taking a photo as opposed to recording a video. And I can import namespaces, everything is good, like you see some system stuff, which is CLR stuff, you see some Windows stuff, which is WinRT interop. So now that I have this guy, what does this thing return? Well, if I would actually go in there and I can use F12 and go to definition and all the things that I'm used to, as you can see, this thing returns a camera capture UI capture file operation. Names in WinRT don't have length limitations, apparently, so things can look a little long. But if you go into there, you see it's an iasync operation that contains a storage file. So that's the way that asynchronous operations are represented in WinRT. Now, the nice thing is, because C# and VB have this thing called async and await, which is based on patterns, we can implement the awaiter pattern on top of this thing. In fact, if I would go here and I would try to dot into it, you see things like start as task, like extension methods. We can implement some extension methods on those guys that allow us to actually get access to the async functionality just by using the await keywords. So I'm going to make this an asynchronous function, and I'm going to say, at this point, let the user take a picture, yield control back to the UI loop so that my application keeps responsive, doesn't rust over, and then when the picture becomes available after the await completes, please assign it to variable file. And if you look here, as you can see, this thing returns a storage file. So that's nice. We can actually get access to the file. Now, what can we do with a file? The file, we can do a variety of things. We can, for example, get thumbnails asynchronously. Might take a long time. We can move a file. If it's a 1 GB file, you definitely want this thing to be async. So you see that there are async APIs for all those operations. And we can also open the file asynchronously, passing in the file mode. So I'm just going to read from the file, as you can see over here. And so now that I do this, what do I get back? Let me call this S. What I get back is a stream retrieval operation. And so I can actually just do stuff here. Well, that's an operation. It's asynchronous. So if I await it, I will get the result out of it. It's an random access stream. So now I've come from presenting the picture UI. User takes a picture. We get this file back. We open it, and we get a stream. And now the stream can actually be fed into an image using bitmap image, which lives in System UI XAML Media Imaging. If you're a Silverlight guy or a WPF guy, you actually know this thing already. You can do image.setSource, where you can now pass in that stream, which I've called appropriately S. And now I can go to my UI control, which I believe I called photo. Likely it will have to generate the g.cs file. Let's see, yeah, so photo is existing now because I saved that XAML file. So that's just a photo, and on a photo I can set a source to be the image. Now, I've forgotten one thing, is that this API, as we've seen before on this thing, has capabilities webcam and microphone. If I want to use those guys, I have to declare in my application manifest that I want to use those guys. So going back here to the properties, not to the properties, to the appx manifest file, which is really an XML file that's rendered by a designer here in Visual Studio, I can go to the capabilities and say I want to have access to the webcam. And so this will actually segue us into an additional explanation of how those capabilities work in just a moment, but let's actually show the behavior of this app. So I have a button, I have a grid or an image control next to it. It's a full screen application, of course. Let's click on the button. And so here you go. Now we actually get a prompt that says, do you want to allow application 5 to use the webcam? The user can say yes or no. This actually happens out of process here. So I will say allow. And now, well, it's just kind of dark here, but let me flip the camera to the front of the screen. And yes, there is somebody here. That's good. It's not very clear. In fact, there's a light here. Ooh, it's not connected. That's a useful light. Okay, maybe it's an asynchronous operation that eventually will yield light. But so I have some stuff going on here. Okay, that's the mouse. I can tap the screen. Here we go. And then, you can sort of crop it. But the crop aspect ratio has been set, so I can only crop it such that it keeps a 4:3 resolution. I can save that, and here we go. Now we have the image, which is really, well, it's kind of spooky. Now we have the image rendered in the control here. So you see, I've used async and await now to interact with the webcam dialog. Ultimately, the operation comes back. The rest of the method keeps executing. I'm then awaiting a file operation, and ultimately, I'm sticking things into the control here. So pretty simple piece of code to actually write. So let's go back to the slides and talk a little bit more about a few more things. It's really dark here when, I'm not in the slides. So what are some Windows runtime patterns? I've shown you a couple of those. I've shown you iVector. I mentioned iVector view, so there are collection types. We've seen delegate types in disguise here and there, like, event handlers. And in fact, we gained some nice things in the CLR based on this as well. For example, typed event handler of T standard T event args is something that WinRT has that the CLR has now as well. We have events, which are just, good old events, which are lists of, callbacks. We have property sets, which is inspired by XAML, where you can actually have collections of items that have different types. We have the async operations, which derive from iasync operation of T, which is like task of T, but then for the Windows runtime. And that actually has great support in all languages, like in JavaScript, you use promises using then, which we've seen for the file picker dialog. When you're dealing with C# and VB, you can just use await. And then finally, we have ways to actually connect applications to extension points, which indicates that those apps are really silos, and if you want to open up communication with other apps, you actually have to go through some APIs that bless, based on a contract, the communication between those guys. So I will actually show you that in just a moment. I'll just add some app-to-app communication here. So here you see some collection stuff. I've already mentioned this. You have different interfaces, including an observable vector, like observable collections in WPF and Silverlight. And then on the right, you have different projections, like, vectors look like regular arrays in JavaScript. They look like IEnumerable of T, iList of T's in the CLR. And then you have like STL-type projections for C++, using begin, end, and all the iterator stuff that people love in C++. Asynchronous objects, we've talked about that before. If an operation can take more than 50 milliseconds, it has to be asynchronous. So really the operations you will find in WinRT that are not asynchronous are things that just set some flags on certain APIs. But the thing that really does the meat of the work, like copying files, capturing images, doing file picker stuff, is long running and actually becomes async. So you have to use asynchronous programming to talk to those things. Because like a single synchronous call can actually tank the experience. And often it's in a certain corner. Like the printer APIs in Windows Win32 typically return pretty quick unless the printer is connected to the network and it's offline. Like there are certain cases where the API can take a long time. Like don't take a risk, just make everything asynchronous. And so async is actually integrated deeply and the language projections surface it very nicely. So here you see the code that I wrote before. In fact, I had to do one more null check there because the user can actually cancel the capture dialog, and then you would get a null back. But so this is pretty much the code I wrote before. Now, just to drive home the point, like how are you able to actually interact with the webcam before in Win32 style applications on previous versions of the operating system? It wasn't something as sexy as this, let me assure you that. It was actually something as ugly as this. Lots of DLL imports to like some magic DLL file where you have to get all the marshalling code right, and there's much more than this. I'm just using 2 functions here, but I need like 10 functions to talk to the webcam. And then you need to make sure you're on the right threading apartments and all sorts of things that you don't have to worry about anymore. You just create a new UI object, you dot into capture file, and it's a nice object-oriented API. No pinvoke.net website anymore. You can remove it from your favorites. Just use the WinRT APIs. So I've shown you this demo, but I just wanted to show you one more thing, how to do interop between applications, or actually communication between apps using those contracts. So I have this whole thing sitting here already. And so what I want to do is I want to use a way to share the picture I've taken with other apps that can accept the picture. So for example, I want to post it to Facebook. So I'm going to use the data transfer manager, which lives in Windows application model.data transfer as a namespace. So I can do control dot, and I get all the rich tooling support to interact with those guys. I can get the data transfer manager for the current window, like this, and I can hook up an event handler. It's an event handler exposed by WinRT, but the way to just hook up an event handler in C# is just += double tap, and there's your event handler. If you do it in JavaScript, you would have to use the way that you hook up events in JavaScript, which has well-defined patterns that JavaScript people know about. So now I have the event handler sitting here, and I can talk back to the arguments to say that I have received, or that I can actually send some data, or I can fail the operation as well. So where do I get the data from? It's actually data that the user has already obtained by doing this whole thing here. What I can send across here is the stream. So when the user clicks on the button, we can actually store away the stream. Let me actually just rename the stream. Oh, I can't rename the stream yet. Okay. Okay, so I will call this thing stream and promote it to become a field. So now I have a field that contains the stream, and then when somebody from another app, by means of the share charm that you have on the right here in Windows, you have this share thing. If you click the share stuff and you want to send some data from this app to another app using the share button, you will get a callback on this data requested event. And then I, of course, need to check whether the user has already taken a picture. So I will say if stream equals null, I want to talk to the args request and say fail with display text, no picture has been taken yet. Else, I can basically tell that guy args request.data set bitmap and give it the stream. And now we're actually sharing to this well-defined contract a stream from one app to the other. And so that's how you do this communication using the data transfer manager. Oh, by the way, actually, if you look at this guy, data requested uses typed event handler of tsender tEvent args. That's something that we have in the BCL now as well, because in fact, WinRT uses typed event handler. So you don't have object sender, you actually do have the real type sender, which is a pretty nice addition as well. So here you could actually go into the sender and deal with that guy as well. So now that I have this, let's actually try to run this guy and see what I can do now. I can go to the right and click on share, and you see no picture has been taken yet. So we actually executed the code that said, do you have something to share? And we came to the conclusion that's not the case. And now let's do that whole dance with the cam again. So I have the cam, I took a picture, and now I can go to the right to share, and you see there's an application that can accept the bitmap. So we actually called, a way to actually share the bitmap stream, and I can send it to Socialite. And now here, I could just share this thing on Facebook, and you see my picture appear over there. The data was transferred across applications, and I could make a fool of myself by putting this on Facebook now. So just making a fool of myself in terms of wacky cam pictures during my session at TechDays. Okay, webcam pictures. Okay, and so now everyone knows that, we've been playing with this. So now it should be on Facebook if you actually go to my Facebook page. If you're not a friend of mine, please add me, and then you will actually see this picture. Okay, so let's go back to number 3, and I think I screwed up. Oh, okay, here we go. And actually do some final notes here. So one more thing that I haven't really talked about is the threading model of WinRT. Well, as It's used actually in many of those UI frameworks. You have a single UI thread, use asynchronous operations, which typically do some work on a thread pool. The nice thing is you don't have to know about it. You just use the await stuff, use all of the capabilities that I've shown you, and things just work out fine. But you can actually access the thread pool directly as well. You can queue work over there if you like to do so. So the thread pool is available to you. Here's some information about threading. Objects can be thread bound like UI objects. They can be thread flexible, that they don't really have affinity to a thread, but then they need some locking around it to use them for simultaneous access. And we also have brokered objects, which mean they live out of process. And so, in fact, when we interact with the shell in Win8, there is some of those out-of-process object communications going on as well to talk to your app and all that kind of stuff. The UI runs in a single-thread environment. It's not re-entrant. It's actually nicer than the classic SDA in various ways. When you're actually at some point waiting for some operations, you can't have re-entrancy. So there are some improvements there. If you're used to classic SDA and you say, oh my God, classic SDA, re-entrancy everywhere, you don't have to worry about that anymore. So that's a great addition. And most non-UI things actually run in any thread. So they're not bound to a certain thread. They can actually complete, ultimately going back to the kernel in an I/O completion port. So what's those brokered objects about? Well, brokered objects is really when you have some broker process, like runtime broker.exe, where an object gets activated and then your app talks to it over some proxy. So that's what you're seeing over here. That's another capability that's in the platform. And in fact, we've seen, in passing when we were doing some demos, like, the webcam prompt that you saw there, in those cases, actually brokers are actually turning around and asking prompts to people and all sorts of things. So that's another facility that's in the runtime. So in summary, actually, I am 4 minutes short, so we could actually answer a couple of questions, but this is the key takeaway. The Windows Runtime is this foundation that allows you to build those rich, metro-style, full-size, immersive, fast, fluid, touch-based applications. That's a lot of adjectives to describe the platform. It's easy to build them. You have rich developer support thanks to the metadata format. So if you're used to IntelliSense, now you have IntelliSense to all of the Windows APIs. In the past, well, you didn't have IntelliSense. You had to do extern declarations, DLL imports, comment drop facilities, all sorts of things. So when it enters Windows, it's directly consumable by all those APIs or all those languages through so-called projections. And so you can use any language of your choice on top, and things look familiar to you in terms of different object models like collection types and asynchronous operations. So with that, I'm actually at the end of my talk. We actually have a C++ Windows Runtime talk here as well. We have some Metro specific talks this week as well. So if you want to learn more about those things, you can actually get more information. So are there any questions? Yep.
Can you also use WinRT objects in desktop applications?
At this point, we haven't said anything about using WinRT objects from the desktop. WinRT is actually the platform based for those Metro-style apps. So there's no host in desktop applications that runs WinRT. You have WWA host for JavaScript-based apps. You have other hosting models for managed code. It's the full screen thing. Like, it looks kind of weird to have a green bar on top of your screen at some point. So no word on using WinRT APIs from desktop. It's really meant for this touch-based experience. Yeah. Other questions? Okay. I think we're done here. Thanks for staying this late, and I hope, with the consumer preview coming later this month, you will start building great applications, fast and fluid, and I will love to actually look at them and use them with, nice tablets. Thanks very much, and hope to see you again.